Hey, in this video we're going to look at 4 trigonometry derivative questions, and they will all be difficult. So all you have to know for this video is derivative of sine x, which is cos x, the derivative of cos x, which is negative sine x, and then derivative of tan x, which is secant squared of x. But these have to be memorized. There's no any other way of finding them out but to memorize them. So if you memorize these, you can basically do any question here if you already know the derivative rules like the quotient, product, and whatever else rule that you need to know. Okay, so yeah, question number 1. Here we have a fraction, or in other words, we have division. So I know that we need the quotient rule. If you remember, to find the derivative of a fraction, it's pretty simple, but you have to follow a rule. So the derivative of y, so derivative of y with respect to x is going to be equal to, so first you find the derivative of the top. So what's the derivative of x squared? It's going to be 2x, and then multiplied by the bottom. So the bottom is 2 minus tan x, so multiply by 2 minus tan x. Okay, that's the first term, and then minus the derivative of the bottom. So what's the derivative of 2 minus tan x? Derivative of 2 is nothing, so we can ignore that. Derivative of tan x is secant squared x, like we said here. So knowing that, the derivative of negative tan x will be negative secant squared x, and then multiply by the top. Okay, pretty simple. So derivative of top times bottom minus derivative of bottom times top, and then all over the bottom squared. So all this will be a huge fraction, and then square the denominator. So 2 minus 10x all squared. Okay, so we basically finished the question. All you have to do is simplify from here. Okay, so simplifying, sometimes it happens, sometimes it doesn't, but the first step you always have to do is expand these brackets, because we don't want two brackets that look like this. So what we would have is that this is equal to 2x times 2 is going to be equal to 4x, and then 2x times negative tan x is negative 2x tan x, and then these two negatives here become a positive, so they cancel. So we'd have plus x squared secant squared x, and then the denominator, we don't have to expand that because there is no way we would simplify to begin with, so we can keep this as 2 minus 10x all squared. And yeah, just like I said, in theory we were done in this first step. Right now all we are doing is simplifying and making it look nicer. Okay, but if your teacher is fine with leaving it as this first step, then you can do that, but most teachers do not allow that. So yeah, and then from here, the dy over dx will be equal to, so what do we have in common on top? We have an x, and an x. So let's factor out an x. We would have x on the outside multiplied by 4 minus 2 tan x plus x secant squared x, close bracket, and then the denominator stays the same. And I'm going to stop here because I don't see anything else to simplify, but if there is, then you would be right as well. But yeah, just make sure you are simplifying the right things, but we can leave this as our final answer, and we are done. So let's move on to question number 2. Okay, question number 2, here we have that y is equal to sine x over 1 plus tan x. For this question, we have a fraction once again, so we know we would need to use the quotient rule. Okay, so how do you do that? First, I'm going to write dy over dx. What that means is that if you have the function y, dy over dx is the derivative of y. So I'm going to draw that derivative of y with respect to x, which is what we're trying to find, derivative of this function. Okay, so after that, so what is this equal to? If you have fraction, once again, let's use the quotient rule. So the derivative of the top is going to be cosine x, so cosine x, times the bottom. In this case, the bottom is 1 plus tan x, and then minus the derivative of the bottom. In this case, what is the derivative of 1 plus tan x? It will be just secant squared x, because the 1 goes away, and in this case, you're just finding the derivative of tan x, which is once again secant squared x, and then multiplied by the top. So multiplied by sine x, kind of like so, sine x, and you have your numerator. That's it. For the denominator, I'll do the exact same thing, just square it. Square the denominator, so 1 plus 10x all squared, and that's it. So from now, once again, like we always do, once you are done finding what the actual derivative is, now you have to simplify it and make it look nicer. Okay, so this will be equal to cosine x, because I'm expanding this bracket, so cosine x times tan x, and then cosine x times tangent of x, and then minus, for this, we can just take away the brackets because they mean nothing. We would have sine x secant squared x, and then for the denominator, that stays the same. So 1 plus tan x all squared. Okay, from here, there's one thing you can simplify. This, once again, you don't have to do this because you are still correct. If you leave it as here, you are correct. But I'm doing this for completion, and since it's going to look even better. Okay, so cosine x stays the same. We can't really do anything to that. Cosine x stays the same. And then plus cosine x times tan x is actually sine x. Because tangent of x, we know, is sine over cosine. So sine x over cos x is tan x. And then imagine multiplying this by cosine x as well. Cosine x. So these cancel, and all you are left with is a sine x. So plus sine x, and then last one stays the same. We can't really do anything to that. So minus sine x secant squared x all over 1 plus tangent of x all squared. And you are done. Once again, you could have left it as any of these three answers here, but the more you simplify, the neater it's going to look, especially since these questions aren't easy. It doesn't really matter. But once you get to more difficult questions, simplifying is going to make it look a lot nicer. Okay, but yeah, so this is question number 2. Let's move on to question number 3. Okay, question number 3, here we have y is equal to cosine of x multiplied by 1 minus sine of cosine x. So here we have two things. We have the product rule because we are multiplying two things, and we also have the chain rule because we have sine of cosine x. Okay, so let's try doing that. So first I'm going to write down that dy over dx, derivative of y, with respect to x is equal to, and then if you remember the product rule, first you'd have to find the derivative of the first one. So what is the derivative of cosine x? It is negative sine x. So negative sine x multiplied by the other bracket, which in this case is 1 minus sine of cosine x. So multiplied by 1 minus sine of cosine x. All I'm doing so far is I'm just following the rules of the product for derivatives. Okay, so this is as simple as it gets. Okay, and then plus, because once again, this is the rule for product of derivatives. I'm going to put the link in my description for the video of that, because I explain it in detail in that video. Okay, and then plus the derivative of this multiplied by the first one. So derivative of this thing here, the 1 goes away because derivative of 1 is nothing. So we would have negative cosine of cosine x, because the sine has a derivative of cosine. And then since we have chain rule, we also have to find the derivative of the inside. So what is the derivative of cosine x? It is negative sine x. So we're going to multiply this by negative sine x. And then all of this, I'm going to close the bracket, will be multiplied by cosine x. So multiplied by cosine x, like so. Okay, so recap to what I did in this step. So we have, I'm going to erase all these arrows. We have the derivative of the first one times the second one plus the derivative of the second one times the first one. And in this case, for the derivative of the second one, I multiplied cosine of cos x, because this is that derivative of sine of cosine x is going to be cosine of cosine x. Okay, because derivative of sine x is cosine x, like we know. So that's what I used here. The negative sign stays. That does not go away, so I put it here. That's why we have negative. And then since we have chain rule, you also have to find the derivative of the inside. So what is the derivative of cosine x? It is negative sine x. So you multiply that by what you have here. And that's how we got this bracket. And then multiplying by cosine x is because that is our first term here as well. So we basically are finished with the derivative. Now what we have to do is simplify. But once again, if your teacher allows it, this is a valid final answer, but I'm gonna simplify even more. So dy over dx is equal to, what I'm gonna notice is that we have a sine x here, and we have a sine x here as well. So I'm gonna factor that out. I'm gonna factor out a sine x, so sine x multiplied by, we would have negative 1 times this bracket. If you multiply a bracket by negative 1, you flip the sign of everything. So we would have this as positive and this as negative. So we'd have negative 1 plus sine of cosine x. And that's it for that one. So I'm going to put a small bracket here because that's I'm actually going to change these brackets. This is going to be curly, this is going to be square. And then after that, so I factored it out from this bracket. Now I have to factor out the sine x from this bracket as well. I'm going to do this in yellow. But if you factor out the sine x, first of all, it goes away. And then the two negatives become a positive, so we can completely ignore both negatives. And then all we have left is cosine of cos x multiplied by cos x. So we would multiply this by cosine of cos x by cos x. And we are done. And then I'm going to close the curly bracket as well. This is a valid final answer, but I might as well... I forgot to do one thing, which is add both brackets. That is very crucial. I almost forgot that. So once you close these, you got to add them because there's a plus sign here as well. Okay, but yeah, so like I said, once you have this, I'm going to actually remove these brackets because they are completely useless. We don't need them anymore because we are adding. Okay, so I'm going to make this look nicer once again, but this is also equal to sine x multiplied by -1 plus... I'm going to actually move the bracket like I said, I forgot that. But -1 plus sine of cosine x, and then plus cosine of cosine x times cos x. And that's it. So we have, I'm going to make this a bracket that looks like that. And we are done. So this was a bit more difficult because we also had chain rule involved. But if you know the steps and you know the rules, there is nothing difficult about this. You just have to follow them. It might be confusing because there's a lot happening at the same time, but it's the exact same steps that you already know with any other simple question that you've seen before. Okay, but yeah, let's move on to the final question, number 4. Okay, question number 4. Here we have that y is equal to sine of tangent of the square root of sine x. So we have almost 4 chain rules being applied, so it's going to be pretty long, but let's get started. So what would the first step be? First step is pretty simple, but you want to always write down that you want to find the derivative of y with respect to x. This tells the teacher or whoever is marking this that you are trying to find this to begin with. Okay, and then what is this equal to? So what does chain rule tell us? It tells us that if you have something that looks like this, you want to find the derivative of the first piece, which is sine, and that will be cosine. Keep the insides the same, so this would be cosine of tangent of the square root of sine x. And then after that, you want to multiply by the derivative of whatever is on the inside, aka the tangent of the square root of sine x. So multiply by the derivative with respect to x of tangent of the square root of sine x. Okay. Once again, you might be wondering actually why I wrote it this way, and the answer is I want to make it easy to visualize. Because usually what we would usually do is write the answer immediately, and we wouldn't show intermediate steps. But yeah, now is the perfect time to show what actually happens behind the scenes. Okay. Now my next step is to find how much this derivative actually is worth. Like, what is the value of this derivative? Okay. So d with respect to dx of tangent with sine square root inside of it is equal to, so first, what is the derivative of tangent? This will be secant squared of, once again, the insides stay the same, so square root sine x, that stays the same, we don't really do anything to that. And then you want to multiply by the derivative of whatever is on the inside. So the derivative of the inside is d with respect to dx of the square root of sine x. Okay, so far so simple, but all we've done is we've done chain rule twice, and we've multiplied by whatever is on the inside after finding what the outer derivative is. Okay, now let's do this one more time. What is the derivative with respect to x of sine x, or the square root of sine x? So d over dx of the square root of sine x is equal to, first, I don't want the square root because this confuses me. I don't want to have the square root there because, once again, I want to look at something that helps me find the answer, not look at something that kind of makes me go back and double check and kind of doubt myself. Okay, so instead of the square root, I'm going to put to the power of 1/2. So this is the exact same as the derivative with respect to x of sine x to the power of 1/2. That is what the square root means. Okay, now it looks a lot simpler. So how would you find the derivative of this? First, you bring the 1/2 down. Okay, so you'd end up with 1/2 multiplied by sine x to the power of, you always decrease the exponent by 1. So what is 1/2 minus 1? This is equal to -1/2. So this would be to the power of -1/2. And then chain rule once again, multiply by the derivative of whatever's on the inside. In this case, the inside is sine x. So what is the derivative of sine x? It is cosine x. So multiplied by cosine x, and we are done. Okay, and I could have done what we did last time in writing d over dx of sine x, but that's pretty simple, so I just wrote the answer immediately, which is cosine x over here. Okay, now let's erase a few of these arrows and unnecessary steps, kind of like so. Okay, now let's actually combine all the answers into this answer over here, because our original answer, or like the first step, was that we wrote this, which is part of the answer, but then this over here is a step that is not solved. But we did solve it after that a couple times, so let's actually put the proper answer into one huge line. Okay, so what this will end up looking like is the derivative of y with respect to x is equal to cosine of tan of the square root of sine x. All I did was I copied this part here, and then multiplied by this part, but this part is equal to whatever we have here, so multiplied by secant squared of the square root of sine x. Then once again, if you multiply by this, you're basically multiplying by what we found over here, so let's put the entire thing down there. So I'm going to put this in orange, but multiplied by 1/2 of sine x to the power of negative 1/2 multiplied by cosine x. Okay, and now we are basically done, because we have everything that we are required to have. You can leave this as an answer. This is completely valid, but I'm gonna make it look a bit nicer, because this is always something that you want to do. Okay, so dy over dx is equal to cosine of tan of the square root of sine x multiplied by secant squared of the square root of sine x. And then the 1/2, this can go to the bottom of a fraction and put a 2 on the bottom. The sine to the power of negative 1/2 can become a sine x to the power of 1/2 on the bottom, but a power of 1/2 is the exact same as the square root, so I'm going to erase this and put a square root sign, and then the cosine x stays on top. So multiply all this by cosine x. I'm going to make the line of the fraction bigger, and we are done. This is our final answer. We can leave it as this, and yeah, basically done. So this is the end of the video. If it helped you, leave a like, because it will help me. But yeah, hopefully you understood, and hopefully I'll see you again in the next video. So yeah, that's it.